Hey guys, Cassidy here. Today we're going to be talking about the last two colligative properties, freezing point depression and osmotic pressure. Okay, freezing point depression. The equation looks like this. It's really similar to boiling point elevation, but instead of using the temperatures of when things are boiling, we're just going to use the temperature of when things are freezing. So our I value is still our Van Hoff factor, our M is still our molality, and our Kf is still going to be a constant that the problem will give you. So let's hop right into talking about the conceptual side of this. So for freezing point depression, the point of it is because it lets you know that when you add a solute, it's actually going to decrease the freezing point. So there's going to be a difference than freezing a solvent that has no solute versus freezing a solvent that does have a solute. So why does this happen? Let's use some drawings. Let's say we have some water over here, and these blue dots are the water molecules, and they want to become ice. They want to freeze. When they freeze, they're going to form stronger hydrogen bond interactions and become closer together. But let's put in some solute. Let's say we're adding some solute to the left, but just a little. But on the right, we add a lot of solute. So what is going to happen when these water molecules try and form those hydrogen bonds? So what's going to happen on the left is that they're going to form those bonds. They're going to become more of a solid because that solute isn't really in the way. There's not a lot of it. But when we look on the right, that solute is prohibiting the water molecule from forming hydrogen bonds. It can't reach out to its neighbor and form that bond because there's something in the way. So because of that something in the way, in order for them to be able to form those hydrogen bonds, we have to lower the freezing point a lot, and that's going to kind of solidify the solute in place so that it's not in the way. If that's confusing to you, just think about using salt on an icy road. You know, when it snows and when there's water on the ground, what we do is we throw salt on it. And because we throw salt on it, it inhibits that water from forming those hydrogen bonds to turn it into ice. It's the same situation. Okay, osmotic pressure. Here is our equation. That M right there, it's not molality anymore. It's now molarity because it's capital. Molarity is moles of solute over liters of solution. Our R value is a constant, 0.08206, and then our temperature needs to be in Kelvin. Okay, definition time. Osmosis is the net movement of solvent molecules from a solution of low to high concentration of solute or high to low concentration of solvent across a semi-permeable membrane. Okay, that was a lot. So let's kind of explain it. So osmosis is basically telling us, how does our liquid move, right? When we're talking about osmotic pressure, we're talking about liquids. How does our liquid move? Our liquid can move from a low to high concentration of solvent or a high to low concentration of solvent. Those are the same thing. Normally, in biology class, for example, you'll hear, okay, diffusion happens from a high to low concentration. Well, in this definition, we're just clarifying. We're clarifying that the net movement of solvent is either from a high to low concentration of itself or a low to high concentration of solute. So what do I mean by that? On the left right here, we have a low concentration of solute, but our concentration of solvent, that blue liquid, is a lot higher, right? Not as much of it is getting taken up by the solute. So when we have a low concentration of solute, it's the exact same thing as saying a high concentration of solvent, right? Because our solute plus our solvent together equals our solution. But over here, we have a high concentration of solute. Look at all those pink molecules, but there's not as much blue liquid, so that's a low concentration of solute, which is why this high concentration corresponds to the low concentration. If that confused you, just think of osmosis as the movement of solvent molecules from a high to low concentration. But in chemistry, they do like to define this low to high concentration of solute, even though the solute is not moving, because we have a semi-permeable membrane that's going to separate our two solutions. So what is osmotic pressure? Osmotic pressure is the applied pressure to equalize fluid levels. So basically, we have these two containers, or these two solutions in a U shape that are separated by a semi-permeable membrane. And that osmotic pressure is just what pressure do we need to get those fluid levels to be the same. So something you can take away from this is that if something has the same osmotic pressure, no osmosis will occur, okay? So this conceptually is a little more challenging to think about, but for the most part, you're just going to be able to want to know how to solve this equation.